Properties of ingredients of concrete. The following are the ingredients of concrete: cement, fine aggregate, coarse aggregate, water, and admixtures. Cement is generally used as the binding material. It is also used to fill the micro voids in concrete. Fine aggregate, we generally use sand as the fine aggregate, which performs the role of void filler. Coarse aggregates, it is the most important material in concrete because it provides strength to concrete. Generally we use hard blasted granite chips. Water is another important ingredient of concrete. It is useful to hydrate cement, and it also controls workability and strength. Admixtures, it modifies the properties of concrete in fresh and hardened state. Now see this figure, you can see three kinds of particles here: cement, fine aggregate or sand, and coarse aggregate particles. It may be observed that the coarse aggregate particles are larger in size and they occupy most of the volume. When they are packed together, you can find void spaces between the particles, and you need something to fill them up, for which you use sand. Sand fills up the voids between the particles of coarse aggregate, yet between the sand particles themselves you will find voids. These micro voids shall be filled up by cement particles. So with the help of three kinds of particles you can prepare a concrete structure of very less voids, and thus the structure becomes more dense. Now let's study about each of these ingredients of concrete. First, cement. Cement is prepared with the help of these raw materials: calcareous and argillaceous materials. Calcareous materials are those materials which contain limestone. Argillaceous materials are those materials which contain clay. Both these materials have the following oxides: calcium oxide, silicon dioxide, aluminum oxide, iron oxide, magnesium oxide, sulfur trioxide, and alkalis, which are also oxides: potassium oxide and sodium oxide. These two materials are then mixed in a definite proportion. We follow the ratio 4:1, that is 4 parts of calcareous materials are mixed with 1 part of argillaceous material. Then it is fed into a rotary kiln, which is a kind of furnace, and blasted at a temperature of minimum 1500 degrees Celsius. As a result, we get what is known as clinker. It is a nodular shaped material which, when cooled and ground into fine powder, we get what is known as cement. The cement which we get thus has the ability to set very quickly. So to prevent such a tendency, we add 3 to 5% gypsum. Now the cement that you get now is known as ordinary Portland cement, OPC. The ordinary Portland cement is analyzed and is found to contain the following major compounds. These compounds are known as box compounds. They are tricalcium silicate, represented as C3S, dicalcium silicate, C2S, tricalcium aluminate, C3A, and tetracalcium aluminoferrite, C4AF. They are written in the order of their composition, and you can find that tricalcium silicate is the most important and abundant material found in cement. Now coming to hydration of cement, you must have a brief idea about what hydration means. Hydration is nothing but the reaction between cement and water. Cement, when reacts with water, liberates heat, and hence that reaction is known as exothermic reaction, and the heat thus liberated is called heat of hydration. And here is written the order in which the box compound gets hydrated. First, tetracalcium aluminoferrate and dicalcium aluminates get hydrated, followed by tricalcium silicate hydrates next. Only after that dicalcium silicate undergoes hydration. And it should also be inferred that since the hydration of C4AF and C2A occurs first, these two compounds are responsible for giving initial strength to the concrete. The early strength of concrete is imparted by tricalcium silicate, and the late strength of concrete is imparted by dicalcium silicate. Now let us discuss about the different grades of cement available in the market. We have 33 grade cement, 43 grade cement and 53 grade cement. 33, 43 and 53 represents the minimum average 28-day compressive strength of 3 cement mortar cubes, which means that if you mix cement with standard sand in the proportion 1:3 and prepare a mortar, cement plus sand is mixed with water to prepare mortar, and you fill it in standard cubes of size 7 cm by 7 cm by 7 cm. Once you cast it, you allow it to set and put it for curing, and after 28 days you take out the sample and perform compression testing. You will get 33 megapascal as an average for 3 specimens. If then that cement is graded as 33 grade, and if you get it as 43 megapascal, you grade it as 43 grade, and if you get it as 53 megapascal, you take it as 53 grade cement.